Open communication standards are the backbone of sustainable mobility and industrial automation. They ensure that systems and devices can interact seamlessly, enhancing overall performance and flexibility. Imagine a manufacturing plant where programmable logic controllers, or PLCs, manage the production line. By adhering to open standards, these PLCs can effectively communicate with charging infrastructure for electric forklifts, ensuring efficient energy usage and operational readiness. This integration not only boosts efficiency but also supports sustainable practices. The parameter you need is interoperability, which enhances system efficiency and supports innovative solutions. Here's why that matters. Open standards allow engineers to create and modify automation programs with ease, tailoring them to specific needs without significant disruptions. For instance, an engineer might use an integrated development environment to optimize the charging cycles of electric vehicles based on real-time data and energy availability. This leads us to the pivotal role of open communication standards in sustainable mobility. Open communication protocols are the backbone of seamless data transmission in industrial automation and sustainable mobility. These protocols ensure that different systems and devices can interact without compatibility issues, enhancing overall system performance and flexibility. Imagine a manufacturing plant where programmable logic controllers, or PLCs, manage the production line. When these PLCs adhere to open standards, they can communicate effectively with other components, such as sensors and actuators. This integration leads to improved operational efficiency and contributes to sustainable practices by optimizing energy usage. For instance, a PLC can exchange data with the charging infrastructure for electric forklifts, ensuring efficient charging and readiness for use. The use of open standards and programming environments allows engineers to create and modify automation programs with ease, adapting to changing requirements without significant disruptions. To start with the initial configuration, you need to set up your environment with the right parameters. Begin by ensuring your PLC software is updated to the latest version. This is crucial because outdated software may not support the latest communication protocols. Next, navigate to the Communication Settings tab and select the appropriate protocol, for instance, Modbus TCP for industrial applications or CA-NOPN for automotive systems. Set the baud rate to 19,200 for legacy devices, but for modern systems, 115,200 is more appropriate. Remember, the baud rate must match on both the PLC and the connected device to ensure seamless communication. Additionally, configure the IP addresses if you're using a network-based protocol. Make sure the subnet mask and gateway are correctly set to avoid connectivity issues. Lastly, enable the Keep Alive setting to True to maintain the connection stability. This setup ensures that your systems are ready to communicate effectively, promoting interoperability and enhancing system performance. Now, let's dive into the practical implementation. Imagine you're writing code for a PLC to manage an electric vehicle charging station. You'll need to set up the communication protocol, typically using Modbus or CA-NOPN. Begin by defining the communication parameters in your PLC software. Set the baud rate to 19,200 for Modbus, and ensure your data bits are 8, with no parity in one stop bit. For CA-NOPN, configure the bit rate according to your network requirements. Next, establish the wiring. Connect the PLC to the charging station using twisted pair cables for Modbus or CAN cables for CA-NOPN. Ensure proper shielding to reduce electromagnetic interference. In your code, implement a loop that continuously checks the charging status and adjusts the power output accordingly. Use flags to indicate when a vehicle is connected or disconnected. Remember, the key to efficient communication is minimizing latency and ensuring data integrity. This means optimizing your code for speed and using error-checking mechanisms like CRC. Now, let's delve into the advanced nuances and edge cases that you might encounter when implementing open communication standards in sustainable mobility. One common edge case is handling variable network latencies. In real-world scenarios, network conditions can fluctuate, leading to inconsistent data transmission times. To mitigate this, implement adaptive timeouts. For instance, if your system detects a latency spike, Automatically increase the timeout parameter from the default 500 milliseconds to 1000 milliseconds. This ensures that data packets are not prematurely discarded. Another critical aspect is error handling. When integrating PLCs with charging infrastructure, you might encounter error code 8001, indicating a loose cable or outdated driver. Regularly update your drivers and perform cable integrity checks to prevent such issues. Additionally, consider the use of redundant communication paths. If one path fails, the system can seamlessly switch to an alternative, ensuring continuous operation. This redundancy is particularly vital in high-stakes environments like manufacturing plants. Remember, the goal is to achieve a robust, fail-safe system that can adapt to changing conditions without compromising efficiency or safety. Navigating the landscape of open communication standards can be challenging, but understanding common pitfalls will help you avoid them. One frequent issue is the misconfiguration of parameters, such as setting incorrect baud rates or timeout values. For instance, a baud rate mismatch between devices can lead to communication failures. Ensure you align these settings across all components. Another pitfall is overlooking the importance of protocol compatibility. Not all devices support every standard, so verify compatibility before implementation. Additionally, underestimating the need for regular updates can lead to security vulnerabilities and inefficiencies. Stay vigilant with firmware and software updates. To master this domain, remember the core values: interoperability, efficiency, and adaptability. By adhering to these principles and avoiding these pitfalls, you'll ensure seamless integration and optimal performance in your sustainable mobility and industrial automation projects.